Students, today's lesson is on graphing linear equations. Let's go ahead and start out with some vocabulary. A linear equation is an equation whose graph is a line. So if the graph is anything other than a line, it's not a linear equation. If it's a straight line, it is. And then solutions to the equation are just the points on the line. So let's look at our first example. We're going to graph the equation y equals negative 2x plus 1. And we're going to use some different values of x. Let's start with 0 because that's usually an easy one. So we'll say y equals negative 2 times 0 plus 1. So we're just going to fill in 0 in place of x. So negative 2 times 0 is 0, plus 1 is 1. So the point 0, 1 is on the graph. We can also use x equals 1. That would be y equals negative 2 times 1 plus 1. Negative 2 times 1 is negative 2, plus 1 is negative 1. So the point 1, negative 1 is on the graph. And then let's use x equals 2. We could use some negative values. We could use whatever we want, but we'll just try 2. So we have y equals negative 2 times 2 plus 1. That's negative 4 plus 1, which is negative 3. So the point 2, negative 3 is on this graph. Now let's go ahead and plot the ordered pairs that we listed right here. So 0, 1, 1, negative 1, and 2, negative 3. So our line will look something like this. That's what our graph looks like. Let's try the next example where we're graphing horizontal and vertical lines. So we have the graph y equals negative 3. Notice there's no x in this equation at all. So no matter what x is, y is negative 3. So if x is 0, y is negative 3. If x is 1, y is negative 3. If x is negative 5, y is negative 3. So we see we have a straight horizontal line here. For b, we have x equals 2. This time there's no y value in the equation, so it doesn't matter what y is, x is 2. So x is 2 and y is 0, x is 2 and y is 1, x is 2, y is 3. Whatever y is, x is 2. So that would be a vertical line. All right, let's try an application here. We're told that a tropical storm becomes a hurricane when the wind speeds, let me move this a little bit here. When the wind speeds are at least 74 miles per hour. The wind speed in miles per hour is given by the equation y equals 2x plus 66, where x is the number of hours after the storm enters the Gulf of Mexico. So if x equals 0, that means it's right before the storm enters the Gulf of Mexico. Then y would equal 2 times 0 plus 66. So y is 66. So we have a point 0, 66. We can say if x is 1, so that's 1 hour after the storm comes in, then y would be 2 times 1 plus 66, or 68. So we have the point 168. And let's go ahead and use 2 also. So y equals 2 times 2 plus 66. That would be 70. So we have the point 270 as well. Okay, so now we need to fill out this graph, and we notice we don't have any labels yet, so we need to label both the x-axis and the y-axis, and then put our numbers on as well, so we need to determine our scale. So let's go ahead and do our hours down here, and we could just count by ones here, so 1, 2, 3, 4, 5, that's fine. Our y-axis is the speed. And this one's a little bit trickier because I don't have 0 is at 66 miles per hour. And I want to figure out when we get to 74. So I don't want to be so scrunched up that I can't see what I'm doing. So I'm going to put this little broken symbol on here that shows this graph is actually way taller than it really is, but I'm only going to graph the part we care about, which is, let's say, starting at 66. So I'm going to put 66, and then let's go ahead and just, I'll label it by 2's. So 66, I'll skip 2, 68, skip 2 to get to 70, 72. Oh boy, that's really bouncing there. 74, 76. Okay, so at 0, we're at 66. At 1, we're at 68. At 2, we're at 70, and so on. So 3, we'd be at 72, and 4, we'd be at 74. That is a key number because that is what we're looking for, is at what time does this become a storm, which would be after 4 hours. All right, so go ahead and try a few on your own, and I will see you soon.